page 69. So yesterday we talked about the rational root theorem and Descartes' rule of signs. So the rational root theorem gives you a list of possible rational roots, and these are the only rational roots that you could actually have. It doesn't necessarily give you all of the roots that you're going to get because they may not all be rational, but that only gives you the rational ones. Descartes' rule of signs lets you determine the number of positive and negative real roots. So that could include our irrational roots as well, but it doesn't include the imaginary ones. All right. So here's what we're going to do. We're going to do both of those things, which we already know how to do because we did that yesterday. Okay, you need to do that later because we're on here. Thanks. Then we're going to work down the list of possible rational roots. Now, did any of you actually do the work I gave you yesterday yet? Okay, so some of them had a lot of possibilities, right? And some of them not so much, but some of them had a ton. So you have to start working down that list. But there's going to be ways for us to kind of narrow down the list so we don't have to do it 1,000 times, all right? It won't be as bad as you might think from the beginning. So, and we try each one doing synthetic division because it's going to be the easiest way to do it. Then when we find one, we use the depressed polynomial. So that's like the thing you get after you do synthetic division, right? And then you continue down the list and until you get a quadratic. Because then when you're in the quadratic stage, you can keep going down the list if you want to. But at that point, it's going to be a lot quicker and easier for you to either just factor it if it factors or put it in the quadratic formula if it doesn't factor. Okay. Synthetic division still works, but again, then you're just kind of guessing at what you've got when you could probably finish it quicker unless you happen to get the right guess. Okay. And then we solve for the other ones. So again, we wouldn't get necessarily all the solutions because we're not going to get the imaginary ones, but we would get the rational and irrational ones coming from the quadratic formula. Okay, so that's just your basic steps. We're going to go through them on the next page. So you just open it up, and on the left-hand side, write this at the top. Okay, we're going to find all the roots of f of x equals 2x cubed plus 3x squared minus 32x plus 15. Okay. And we're going to just use this whole page because some of them are going to take a lot more room than others, just depending on how many solutions you could possibly have and all the good kind of stuff. All right. So the first thing that we want to do is get a list of possible roots, right? So our possible roots, and remember they come from looking at this number and this number, and we're going to make a fraction out of it since we have values greater than 1 on both of them. My factors of 15 are 1, 3, 5, and 15, right? And then 2 is just 1 and 2. Because we're going to have to use synthetic division and go down our list of roots. Now, I can go down the list however I want to. I don't have to go down in order, but it's going to be easier for you if you have some sort of method to this. So if I start and I do all of my possibilities starting with 1, and I do 1 over 1, and then 1 over 2, then 3 over 2, and 5 over 2, I'm going to get a whole bunch of fractions first. Would it be better to try whole numbers or fractions in your synthetic division? Like, which one's easier? The whole numbers for sure. So maybe you want to start your list with all your whole numbers and then put the fractions at the end. Even if the fractions are at the front, you can start at the end of your list. It doesn't matter. I'm just saying, find what works for you. So if I want to just get all my whole numbers first, then I'll go through all of these over this first one. So 1 over 1 gives me plus or minus 1. 3 over 1, so plus or minus 3, plus or minus 5, plus or minus 15. Then I got to do the other ones. Then plus or minus 1/2. Plus or minus 1/3, plus or minus, oh, no, I'm sorry, what am I doing? It is not 1/3. What is it? 3/2. Sorry about that. I was doing the 1. It's 1 over 2 and then 3 over 2. My bad. 1/3 doesn't make any sense. 3/2 plus or minus 5/2 plus or minus 15/2. So there are 1, 2, 3, 4, 5, 6, 7, 8. We get 16 possible roots, but don't worry, you're not going to have to do synthetic division 16 times. Okay. How many total roots could I possibly have? Period. 3, right? There's can only be a total of 3, and it is possible that the first one I get is all the way down my list, depending on where I start. But that it won't be as bad as what you think. Then we got to look at Descartes' rule of signs. So that's our total possible roots. Then we're going to look at how many positive real are a possibility and how many negative real are a possibility. So positive real means that I look at f of x, and all I really care about is the signs. So the first term is positive, second term is positive, third term is negative, fourth term is positive. You don't have to write this out. You can do it straight from the function. Doesn't matter either way, right? But what we're looking for is the sign changes. How many sign changes are here? 2. It goes from positive to negative and then from negative to positive. That means my positive real possibilities is 2 or what? 0. So then my negative real, I'm looking at f of negative x. So we can rewrite it as a function if you want to. I wanted to show you that yesterday so you understood where it comes from. But when I plug in a negative x, is my first term positive or negative? Negative. Is the second term going to be positive or negative? Positive. What about the third term? A positive, because if I put in a negative x there, it's going to become positive, and then the last one is positive. That was confusing you yesterday. You got that now? Does it make sense? Okay. Everybody else okay? And then so many sign changes? 1. So of all these 16 possibilities that I have, if you get one that works that's negative, you don't have to try any other negative answers because you know there's only one negative real answer. Does that make sense to you? So that kind of helps you. That's one way to be able to narrow it down. And if you get to 2 of the positive ones, you're done with all the positive ones as well. But we don't need that to get down to 2 of them. Since this is a cubic, I only need to find one that works to get it down to the quadratic stage, and then I don't have to worry about synthetic division anymore. Unless you want to continue, because again, it does work, but it's a little bit more work than you want. All right, everybody good so far? So now we start, and again, I would suggest that you start with the whole numbers because, yeah, the fractions are a possibility, but, you know, hopefully at least one of them is a whole number, and we only really have to find one with synthetic division. So we're going to start with just a positive 1, okay? So positive 1, and then what goes across the top, because I can't see my function anymore. 2, 3, negative 2, and 15. So I bring this 2 down. 1 times 2 is 2. That gives me 5. 1 times 5 is 5. That gives me a negative what? 27. 1 times negative 27 is negative 27. You get negative 12. So is 1 one of the roots? No, it is not. But I do know that f of 1 is negative 12. Maybe that helps me in something else, but it doesn't. So 1 does not work. So then I'm going to try negative 1. Let me write down 2, 3, negative 32, 15. So bring my 2 down, gives me a negative 2, 1, negative 1, negative 33, positive 33, so that gives me a 48. So does negative 1 work? Nope, sure doesn't. Okay, so now I'm going to try 2. I'm going to use 2, 3, negative 32, 15. Oh, 2 isn't one of our factors. Dang it. So then I don't want to try 2. I want to try what? 3. Let's change up 2 or 3. Yeah. Make sure you change the factors. See, I was seeing if you were paying attention. Don't try numbers that aren't in the list. All right. Good job, Shelby. All right, so I bring down the 2. So would 2 have worked if I used 2? No, you're guaranteed for it not to work because it's not even on the list, right? So 3 times 2 is 6. That gives me 9. 3 times 9 is 27, so that gives me a negative 5. 3 times negative 5 is a negative 15, so that gives me a 0. So is 3 a root? Yes. So 3 is a root. This right here is your depressed polynomial. Oh, gosh, I can't spell either. Not because he's sad. Okay. Depressed polynomial. So what I want you to, we're going to go ahead and rewrite what we actually have here so you can think about what's going on. We've got f of x equals, since this is a root, it's x minus 3 times, now this was a cubic, and we've taken one factor out, which means this is our x squared term. So I've got 2x squared plus 9x minus 5. Everybody with me? Okay, so here's something else that this may or may not help you at this point. Like right now, I don't need to do synthetic division anymore. But if I did, my possibilities for my list up there have changed, because now what I'm really doing is trying to find the factors of this, right? So my possibilities have changed because this is no longer a 15 right here. This is a 5. So my only possibilities are ones that would work if I've got 5, 1, and 5 as my factors on top and 1 and 2 on the bottom. So of what I've used, let's go back up here to our list. I don't think you can see both of them at the same time. We've used these. Neither one of these worked, right? Okay, the 3 worked for us. But now because, and I'll rewrite what I had. Now because I've got the -5 and the +2, it's 1, 5, and then 1 and 2, which means that eliminates some other things. 15 is no longer a possibility. Okay, would 1/2 still work? Possibly, yes. What about 3/2? No. What about 15/2? No, but 5/2 would. So now if I did need to keep going in my synthetic division, there are some that I don't need to try at all. Okay, do I even need to try the -3? No, +3 work, -3 is not. So if you did want to continue with synthetic division, you have way less that you would want to actually try. You don't want to waste your time with the other ones. Does that make sense to you? Okay. But because we're down to a quadratic, we don't need to continue with synthetic division because I have this, so I can try and factor this. Now, the other day, I showed you that I wanted you to kind of keep it all together and rewrite everything every time, and then I clarified on that because I wanted to make sure that it was the, God, I lost the word again, something about equality disconnect or something like that. If you're going to go off to the side and do something, that's okay as long as you put it back in there. But let's say that I'm going to just factor this right now, and I don't necessarily want to rewrite everything. If I just factor this, if I put equals to and then whatever that factors to, that doesn't make any sense because it's not equal to the whole thing. Does that make sense to you? So you got to be careful where you put your equal signs and where you leave them off. But I'm just going to take this and go over here and factor it, right? So if I multiply 2 times a -5, that gives me a -10. So I need 2 numbers that multiply to give me a -10 and would combine to give me a +9. Okay, so 2x squared and then 10x and 1x, and which one's positive? The 10x, right, and then -5. Okay. I would suggest by grouping by this, but if you have a different way, that's fine too. This gives me 2x times x plus 5. Factor out my -1, and I get x plus 5, which means this becomes x plus 5 times 2x minus 1. And then I can put that back in here. So that'll give me f of x equals x minus 3 times x plus 5 times 2x minus 1. Okay. Everybody okay with all that? So we've already done all these pieces. We factored, we've done synthetic division, we found roots if I gave you a root, but now you're not given that first root, you have to go and find it. So now that we have this, our end goal is to actually find all the roots. So our actual roots here, not just the possible ones, are, let's see, -5. Then what is this one going to give me? 1/2. And this one gives me 3. And there are my 3 roots. They are all real. They are all rational. Exactly. Right. Yes, because from the beginning it's a cubic. The degree is 3. There could be at most 3 in this here, but I could have a double and triple root, and them still all be rational and real. I could have imaginary roots possibly, so maybe I didn't get any in here. Maybe none of them work. I didn't give you any of those that had like 16 possibilities and none of them worked because that's just mean. All right. I mean, that is that is something that could happen to you at one time. I'm just going to tell you right now, if you feel like that's happening on your homework, something isn't right, because you shouldn't have to spend like pages and pages of homework. Some of them you're going to have to try a couple of things and you're not going to necessarily know what to guess at, and that's okay, but you're not going to have to go through 5,000 of them. I made sure that those weren't the ones that we chose. Okay. Well, I have at most 3, right? So at most 3, and then I know that I could have at most 2 positive real ones and 1 negative real one. So even when if I got to the negative answer first, let's say I tried -1 and it worked, I don't need to try any of the other negative ones, right? Once I get 2 of my positive ones, then I'm good. But it is possible. This just says real. It doesn't say rational, and it may not be in this list. So just because there's 2 or 0 and there's for sure one of them, this one doesn't have to be in this list because it might be a negative irrational answer, okay? But they are real. Everybody good with all that? Any questions at this point? Okay, so let's go through another one. So on the right-hand side, write this one down. We're going to find all the roots of f of x equals x to the 4th plus 2x cubed minus 5x squared minus 8x plus 4. And the problems that I'm giving you, I'm going to give it to you on another sheet of paper so that you're not trying to cram everything everywhere on one thing. But the ones that I'm giving you to do are the same functions that were on the paper I gave you yesterday. So you've already gone through and found some of the possible roots and found some of that, so you're not going to have to do it again. You can just write it over there before you turn it in. Just make sure that you know. I even numbered it so it would match. So the numbers on the paper I'm going to give you don't make sense, like jump around, because they match the one I gave you yesterday. Yeah, the white paper. So I just wrote the same function, like number 2. It's the exact same one on number 2 as yesterday. And yesterday, all you had to do was come up with the possibilities. So you can just, if you already done that, then you just transfer it to the one on tonight's homework. You transfer it on there, and then you're going to have to go through and do the rest. But you won't have to redo it. Okay. Mm-hmm. No, because, well, you do need to include it on the synthetic division. On the synthetic division part, yes. On the sign change part, no, you don't have to include that. That's a good question. Anything else? Okay. All right, so we're here. We got to start. This one doesn't match the worksheet from yesterday, but we're going to find all of the possible roots first. Now this one's a little bit easier, right? Because this leading coefficient is 1. So really all I need are the factors of 4. So that is plus and minus 1, plus and minus 2, and plus or minus 4. Okay, so they're my possible roots. Then I've got to find the number of positive real. That's for f of x. So when I look at these signs, it's positive, positive, negative, negative, positive. How many sign changes is that? 2. 1, 2. So that means this is 2 or what? 0. Okay. Then my negative real is when I look at f of negative x. So my first term, would my first term be positive or negative? Positive. The second one would be negative, then positive, then positive, right? How many sign changes is that? 2. So then here it's 2 or 0. So this is has a degree of 4. It's a quartic, which means I'm going to have to do synthetic division until I need 2 successful synthetic divisions so that I can get down to the quadratic stage. You with me on that? So we're going to start with the positive 1, and then the rest of this is what it is. 1, 2, negative 5, negative 8, and 4. And always double check yourself. On more than one occasion, I have written the wrong numbers down when I did that. Or no, it wasn't always the wrong numbers. I would just put a 1 instead of whatever because I was more focused on the sign. So. All right, so bring my 1 down. 1 times 1 is 1. It's 3. 1 times 3 is 3. Negative 2. 2. Negative 10. And 6. So does the positive 1 work? No. Okay, so now I'm going to try the negative 1. And so using 1, 2, negative 5, negative 8, and 4. Am I going too fast with that, or y'all, I mean, synthetic division, pretty simple, especially when the numbers are easy. So 1 gives me a negative 1. Gives me a negative 1, so that's a negative 6, 6, negative 2, 2, and 6. So that one doesn't work either. So now I'm going to try positive 2. That is on my list this time, right? Yes. I can't see my list. 1, 2, negative 5, negative 8, 4. 1, 2 is 4, 8, 3, 6, negative 2. Okay, so does 2 work? Yes, 2 works, right? Which means this right here gives me my depressed polynomial. Now, you don't necessarily have to write the next step every single time, but I want to write it because I'm not sure that all of you have a great connection of what this even means. So what this is telling me here is that f of x is equal to, well, this is a root, so this would be x minus 2. I started with a quartic, so this right here is my x cubed term. So this is x cubed plus 4x squared plus 3x minus 2. Okay, that's where we are right now, right? Now when I look back up at the top up here, I'm going to go all the way back up here, and the 1 and negative 1, they didn't work, right? The positive 2 worked. Okay, we haven't tried negative 2 yet. But when you look at what you have with your depressed polynomial here, this has changed, right? So if I use the rational root theorem on this, my only possibilities are plus or minus 1, which we already know doesn't work, and plus or minus 2. Is plus or minus 4 even an option? No, so we've narrowed it down to, can't be that one anymore. Negative 2 is the only one that I haven't tried. Does it guarantee me that negative 2 works? No. Okay, that's just a possibility, so I still have to try it, but now I only have one more I can even try with synthetic division. And so now I'm going to use the negative 2, but I'm going to use my depressed polynomial this time, not this. I can use this one, but the whole point is me trying to reduce this down. So now this is 1, 4, 3, and negative 2. This is going to give me 1, negative 2, 2, negative 4, negative 1, 2, and 0. So this is my other one. So it does work, okay, which is good news. But again, it wasn't a guarantee, so you can't just assume that that's going to work because those are only your possibilities. They could be imaginary. So now what I have is f of x is equal to x minus 2. This gives me right here an x plus 2. And then my depressed polynomial right here, these are 2 of my x's, so that has to be an x squared. Get x squared plus 2x minus 1. So I am not finished. Right there, can I factor that quadratic that I have? Is it factorable? What are the only 2 numbers that multiply to give me negative 1? A positive 1 and a negative 1, right? Is there any way to combine the positive 1 and negative 1 to get me a positive 2? No. So can I factor this? No. So then what do? Quadratic formula. And because half y'all didn't listen to that song, I'm going to make you listen to it right now because I want it in your head. I know. Some of y'all were singing it in your sleep lesson. It's real cute. It's better than me singing, I promise.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Pop goes the weasel.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Nice harmony, right?
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
One more time. It's like Barney, it's going to repeat.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
There you go. Okay? Know it, love it. If you need to sing a song in your head, whatever you got to do, but make sure you don't mess up quadratic formula because that is definitely old stuff there. All right. And where was I here? Okay. So now we're going to do that. And we know that the quadratic formula is x equals, I'm not going to sing it, you don't want me to sing, negative b plus or minus the square root of b squared minus 4ac all over 2a. So I plug that stuff in, and I'm going to get negative, and I'm only working on that one. So negative 2 plus or minus the square root of 2 squared minus 4 times 1 times the negative 1, all over 2 times 1, which is just 2. So that's going to give me negative 2 plus or minus. All right, so 2 squared is what? Wait, I did something wrong. What did I do wrong? Oh, I didn't do anything wrong. Sorry. I was thinking I was supposed to get another number. 2 squared is 4, and then negative 4 times negative 1 is what? Positive 4, right? So what's 4 plus 4? 8. So I get the square root of 8 all over 2. Is 8 a perfect square? No. Can you simplify the square root? Yes. So this gives me negative 2 plus or minus, what does this reduce to? 2 squared of 2 all over 2. Okay. Can I reduce that? Yes. Can I cancel these 2's out right here? No. That guy lives in another world. But since I can divide 2 into all of them, that is going to reduce down to what? Negative 1 plus or minus the square root of 2, right? Everybody okay with all that? So that is how many solutions there? 2, okay? So that's 2 of my roots that I need. So that's what I get there when I do quadratic formula. So my final answer, which is supposed to be the roots, I get 2 of them from here, which is this, and then I get the other 2 from here. So my actual roots that are my answer are going to be negative, or it's, actually I can just put plus or minus 2, right? Because it's a positive and a negative 2. So I can put it together like that. And then negative 1 plus or minus the square root of 2, and there's all 4 of them. None of them are imaginary. We good? Any questions at all? No? All right, awesome. Okay, then I'm going to give you your homework.